This is going to be a review of Upwelling and El Niño exam questions. This is for section 2.3, learning outcomes 4 through 6 in the AICE Marine syllabus. So in class, we've started building with what upwelling is. And so I'll do the same. I'll just start with number 4. And if you already have it done, you can skip through this. We've explained what is meant by the term. Explain what is meant by is going to imply that this is going to be a little bit more than just a definition. 2 marks. All right, there we go. And explain meaning like if you can give an example of, give a reason for. Okay, and this is going to be then, it's the movement. I'm going to change this pencil. I don't like it. Of cold, nutrient-rich water from the seabed to the surface. Which implies that it's going to be a current because currents move continuously in a certain direction and moving up. And sorry, there's your second mark there. And marks are denoted with bullet points. And then we can give a reason for why this is happening. You can say caused by offshore winds. Okay, we'll move on to then what we did recently in class. To number 2, describe the role of wind in the process of upwelling. So describe, we're going to need to say what, and this question actually will even feed itself to why. So describe the role or like the purpose of wind, what wind is doing in the process of upwelling. It's 4 marks. We can say wind blows water. I'm going to include in a direction because even though we didn't include that one in class, wind blows water in a direction was actually a mark for a different question that was very closely related to this. And if we also say that it blows it offshore, then you'll get another mark. Slashes mean you could say this or you could say that. So offshore or away from shore. And then what's going to happen when that occurs? So we'll zoom in here. All right, so this is our ocean. And then we're going to have the wind blowing water, and it's going to actually move like this top surface layer away. And what gets created there is going to be an area of low air pressure. My bad, low water pressure. And things in nature don't like when there is any sort of gradient, any sort of difference. So that pressure gradient is a problem, and water needs to take its place. And so we're going to have water moving from the seabed. That's the only place it's going to come. And in addition, it's not just water that's moving up. It's also going to be nutrients that have sunk to the bottom. Because nutrients have mass. This could be detritus, fecal material, any larvae, dissolved nutrients. Those things are going to move up to the surface. And that's going to be helpful in further questions because that's where our producers are. It's where phytoplankton is, and they need this inorganic form of nutrients to synthesize more biomass, synthesize proteins, synthesize DNA, obviously to assist them to make glucose and further photosynthesis. And that's going to be what's fueling our food chains. And in class, we did say this is the first step, blowing water offshore. The second step is this low water pressure. And then the third step that's going to occur is that dissolved nutrients are going to be moved up. And so this is essentially what the process of wind is for this answer. So this creates an area of low air pressure. I keep saying air pressure, water pressure. And water from the seabed will rise up to fill the pressure gradient. Okay. 3C, easy one. The process that brings water from the seabed to the surface, that's just going to be upwelling. And all these are just a combination of questions from many tests, but they're just all about the same topic. Okay, we can build on this now. Explain how wind and the shape of the seabed will produce currents and upwelling. So you have a couple of things going on here. Command word being explain. Explain means we're going to need to say why. How, so why and how is going to explain. Wind and the shape of the seabed produce ocean currents and upwelling. So we'll need to discuss wind and what wind is doing to produce an ocean current and upwelling, and shape of the seabed, same thing, producing ocean currents and producing upwelling. When in doubt and you have an explain command word, you can give a definition. If you're not sure where to start, this is a great place to start. We have two things we can do a definition for. You can do a definition for current, and you can also do a definition for upwelling. And we have currents are the continuous movement of water in a direction. And then your definition of upwelling. Movement, just much more simple. Don't write it like that on a Cambridge exam. Movement of cold, nutrient-rich water from the seabed to the surface. So the definitions. Okay, and now we can actually tackle the main part of the answer, which is explaining how these things are happening. And where I said on number 2, wind blows water in a direction, this is where that's actually coming from. just going to add context in parentheses. Upwelling caused by offshore winds. So the main portion of this mark is that you're mentioning offshore winds and relating it to how this is going to force upwelling. But doesn't have to be this exact, doesn't have to be the exact sentence. We just need to be referencing offshore winds. This is within the same mark. They cause an area of low water pressure this is going to cause deep water or water from the seabed rise to the surface. Again, doesn't have to be this exact sentence. And then if you hadn't stated it yet, then we can say it now. This results in upwelling. We can also mention the inverse of this. It's not explicit in the question, but it is something that was added. If on the exam, maybe you wrote something, what I'm going to write next, I'm going to reference downwelling. But if you did write that, even though it doesn't ask in the question, if it wasn't accepted as a mark, you're not going to be it's not going to be held against you. It's not going to negate anything. You're not going to lose marks, provided it's correct science and it's not a contradiction. But if it's just not there, you just won't get any marks, and that's not a problem. Onshore winds cause downwelling, and it's really just going to be something like this. Winds are pushing towards the shore. There's not much place for water to go, so water at the surface is going to get pushed down. Okay, so that was the effect of the wind. And I'll put the last one right here. Maybe. Is there an order? Oh, it's in the front. Why won't that go in front of text? Okay, I'm not going to struggle with this anymore. We need to mention the shape of the seabed. I will finish it off down here. So we discussed this last week actually. I'll look at this picture that I already drew. So if you have like a seamount or a submarine volcano, a mid-ocean ridge, you have some structures at the seabed, and then we are having water flowing through at the bottom. So you have your bottom currents, those deep water currents, remember they move from thermohaline circulation, so that's all density based. But water needs to go past it. It can't go under it, it can't go through it, and so it gets deflected up. And that is another form of upwelling. Okay. So just how this can happen. Underwater volcanoes. or seamounts, submarine volcanoes. On the seabed, another statement we can say that will get you a mark. Causes water to be deflected up. Make sure we have deflected. Again, this is causing upwelling. And all of these are supporting the other portion of this question, which told you to talk about currents. We did take care of that when we stated what a current was. It is a continuous movement of water in a direction. Okay, moving on the next page. Off the coast of Africa, the west coast of Africa, is the Benguela Current, similar to the Humboldt Current, but different continent. This question is also going to be very similar to one we just did. So areas, upwelling areas like the Benguela upwelling on the west coast of Africa have benefits of upwelling all year round. Explain how upwelling is going to occur. So if you're thinking about what you just wrote about, this is going to be supporting that. We're going to want to talk about the winds first. And this command word being explain, why and how. Winds blow water offshore. Now this question is only 3 marks. The one we answered previously was 4. Very similar question. An area of low water pressure is created or formed, develops. Okay, and then something has to come up to take its place. Cold, nutrient-rich water. And if you don't say nutrient-rich, that's okay. You don't have to say it necessarily in this statement, but we will reference the nutrients in the next one. Rises from the seabed to the surface. And I'm going to actually cut this really quick. It's its own mark. I'm going to put to replace the water at the surface. Because if we're just saying it's going to the surface, we're not fully explaining, like we're not really saying why. And if we just say it's going to the surface, that's just a statement. We're not really saying like why it's doing that. It's for replacement. I just got ahead of myself. All right, pause if you need to. I'm going to move on. So how is this going to benefit local fisheries or fishing companies when there's year-round upwelling? So we need to start with then nutrients. Upwelling brings nutrients to the surface. And I included an image I created here at the bottom. All right, and we have the winds blowing water offshore. You have that area of low water pressure form. There's our cold water and the nutrients that move up with it. Now, the nutrients cannot be fed to animals. Fish do not eat this. Fish do not eat this. If we start talking about fish right away, then we're going to lose the marks the rest of the way. What's able to eat this, or eat this, not eat this, they don't consume, they're producers. What's able to take these in are producers. Producer population is going to grow. That's going to allow your zooplankton population to grow and small fish population. Small fish brings out bigger fish. It's not sad. We'll just pretend it's like a grouper. Okay, even bigger fish. So you got some predators. A lot of feeding frenzies. Some whales. All right. But the question's talking about fisheries. Fisheries are like fishing companies, so fishermen, fisherwomen. So we need to consider the fishermen. And that's where the question, or rather the answer needs to finish itself, is at that final like human level. And if it's benefiting fisheries, we're implying it's benefiting a company. So we need to talk about some money situations. So this allows producers to synthesize. We don't want to say to make. More biomass. Bio means life. Mass is like the stuff that they have. So living tissue. Things that are not living tissue, that are not considered biomass, would be like some blood, bones, teeth, fur. Those things are not going to generally be consumed at all by what we'd assume most to be like a consumer. Of course, there's very specific niche animals like worms that are specialized to burrow into bones and help dissolve those, but that's very specialized. In general, those things are not biomass. Everything else will be biomass. We can also refer to this as organic material. What we're not going to call it is food. Okay, and if we have more producers, again, the food chain's going to follow. So this will increase the population. You could also say this will increase the size of fish. And you don't really have to go through all your trophic levels. Like you don't have to talk about zooplankton. You can, it's not wrong. Totally can. So it'll increase the population or the size of the fish. And this will result in more profit for fisheries. All right. Let's skip this one for a moment. And we'll skip this one. So this is an exam question that I added on. It's from a previous year. And actually, I'm lying. I'm going to skip that because that's specific to El Nino. So I'm going to go to question 7 then. This is the last one you guys actually have on your exam questions. Two maps are shown here. Okay. This will result in weather pattern changes. El Nino occurs every 3 to 5 years. There's weather pattern changes in the Pacific Ocean. So there's two maps, Map A and Map B. Map A shows normal weather and sea temperatures in the southern Pacific Ocean. And Map B shows what happens during an El Nino event. And similar to what you should have done on your notes, I'm looking at the normal first, so Map A. And the first task you're given, it says, on Map A, draw an arrow to show the direction of the prevailing winds. This kind of question is the most missed type of question on exams because there's no lines associated with it, but we're not looking for lines. We need to be looking for brackets that tell us that there's marks available. So draw an arrow to show the direction of the prevailing winds, and that's here. If we think about a compass, our winds blow east to west. These are equatorial winds or trade winds. And they go in this direction. Okay, I'll just talk this out really quick. What we should have done on the notes with any of the coloration. We're moving all of this warm surface water from the west coast of South America by Peru and Ecuador. We're moving all of this warm water over here to Australia and Asia. All right. And then what occurs because of that, those winds are blowing water offshore, so off the coast of South America. The winds are blowing away from there. So we have a lot of upwelling that's going to happen. Of course, what's going to come with that is nutrients. And it's a lot of cold water. So we have cold seawater piling up over here. That's all from the upwelling. For South America, specifically what this is going to do, again, it's going to bring up those dissolved nutrients. And nutrients are going to be taken in by our producers first. So our phytoplanktons, our floating producers. When you have a lot of phytoplankton, then you're going to have a lot of zooplankton. Zooplankton are like animal larvae, but they could also be like jellyfish. Zoo meaning animal, plankton meaning floater. We'll also have a lot of small fish here. This is where a lot of our anchovies come from, and sardines. And again, you'll also have larger fish. And your predators. That's good for money here. And when you're doing your exams, we don't want to do a dollar sign because that is American. It's an international test. They're going to get a lot of money here for just the selling and exports of these fish. And there's also going to be like food sources for the locals. In Australia, they have it drawn in, you're going to have a lot of precipitation. That's good for Australia. there's raindrops coming down. So this is going to prevent a lot of their wildfires. And it also, because the winds are blowing over the water, and it's not just warm water, it's warm air, it's going to cause a lot of evaporation. And all of that warm water moves up and it will condense. And so you have precipitation. And it's also really good for Asia because they have rice crops and they need to grow in flood plains. So over here, we'll also have food sources. This precipitation is also going to remove a lot of the heat from the ocean. So instead of it being within the water molecules, it's being like transferred into the atmosphere, and then we have precipitation. So this is a normal situation. Let's look at El Nino. So we look at the weather and sea temperatures during an El Nino in the southern Pacific Ocean. This is on B. So in El Nino, you could have two things happen, and both of them are going to have the same result. So you either have weak trade winds. Okay, so they do have a difference in their arrow sizes. Or another thing that will happen is the trade winds reverse. And so instead of going east to west, they go this direction. All right, regardless of what direction you would respond with on your exam, the results are going to be the same. So all the warm water that was over here is now going to be piling up over by South America. Again, either because the trade winds are blowing in that direction, they're blowing this direction, or because you have very weak trade winds. And if it's weak, it's not pushing it far offshore. It's staying off the coast of South America. And you'll have colder water in Australia, Asia. Now, a lot can happen here. In South America, in a normal situation, we have upwelling. Here, there's no upwelling because you have onshore winds. Water's getting pushed towards the shore, so there's no area of low water pressure where water from the seabed is going to come up and take its place. So you do not have any upwelling. That's not happening. Fish that live there are used to having cold water. So this water is going to be too warm for them. They die. Or they migrate away, or they migrate deeper to where it's going to be colder. That's going to cause less money from their food sales or their fish sales and less food for the people who live there. All of that rain has landslides, mudslides for South America. This is a very mountainous region over here. In Australia, we're not having really any of that. Because you have weakened trade winds, you're not really having any of that warm air blowing over Australia. And so they're not getting any of that heat that's locked in the ocean to evaporate and then condense and precipitate. And so Australia is going to have wildfires. You're not going to have precipitation happening in Asia, so you're not going to have as much food. Could cause famine. We're not having precipitation, so we'll have drought, again, causing those wildfires. There's not going to be any bad weather, so we can say, because there's no storms, they're going to have higher air pressure. There's not going to be any hurricanes or cyclones or typhoons. They don't have hurricanes over there anyways. The temperature difference in the ocean is going to make it unsuitable for corals to live there. So you have death of corals. Corals are a nursery ground. They're a very biodiverse place. Fish are going to migrate to areas where the water is going to be more suitable. And honestly, it's areas where the water is going to be a bit colder, so deeper waters again, because there's nowhere for that ocean heat to go. You don't have air blowing over it like you did in a normal situation. Loss of fish and loss of corals is going to result in low biodiversity. Okay, so they said use the image describe how, so it's like an explain and a what, like so describe is what, whoops, and then the how is essentially like your why. So what's happening and then why. The conditions will be different in the Pacific Ocean during an El Niño event. So they want to talk about picture B. This question's only 2 marks compared to the one that was given last year. And they want us to look at this picture, this one mainly here. So talking about the temperature inequity there. The temperature could be warmer in Australia if their picture looked like the winds were just weakened. When we're talking about this, we need to have a comparison. So like, how is it going to be different? So we need to show a comparison. So we talk about the seawater first. We are using the figure because it says cool seawater temperature. And notice the cooler. That's implying that we have a comparison. Likewise, quotes mean whatever I wrote above it, you can write below. It's the same thing, same starting sentence. Seawater temps are warmer than normal. And I suppose I should definitely give a location in South America. And this one is going to be in Australia. And again, we're just using the picture. The other thing in the picture is the precipitation. There's increased or higher rainfall. In South America. Or you could say there is lower or less rainfall. This is within the same marks, so you don't get 2 marks for saying this in verse. In Australia. Describe, which means what, and explain. So give a reason for what and why. What are the effects of the El Nino event on fish populations off the western coast of South America? That's where the Humboldt Current is. And then we need to give a reason for that. So the first thing you have to do in order to get full marks for this, you have to describe what the effects to fish populations are. Fish population is the amount of individuals in a species or in a group in that habitat. So that's a number. Numbers can go up, they can go down, or they can stay the same. We typically don't talk about things staying the same. That's the first thing we have to say. And it's going to be that fish populations are going to go down. Dead fish. There's a decrease in fish population. Or we could say there will be death to cold water fish species. I'm saying cold water fish species because this is not going to be a suitable condition for them. Typically, this is what they like. This is the normal situation. But now we have warm water. So we have to have this, the effect. And then the rest is going to be reasons for. So we have to have this. This is one of the marks. All right. And this is all going to be because there's, we could talk about the weather. We could also talk about a lack of upwelling due to lack, and doesn't have to go in this exact order, of nutrients to the surface, causing less upwelling. All right, the phytoplankton population decreases, or you could say primary productivity will decrease. Productivity is the rate. Rate is a speed. So this is how fast something's happening. And what they're talking about is the speed of primary production. It is the speed of photosynthesis. So they're not going to be doing photosynthesis as fast because they're going to have less inorganic material to do that with. They're going to have less nutrients to do that with. They won't be able to grow as fast. They won't be able to make proteins as fast. They won't be able to reproduce as fast. There's going to be less of them in general. Okay, so that's going to otherwise just cause a lack of food source. Alternatively, we can also talk about rain, the rain that is happening. So increased precipitation, I'm just going to put precip. Could cause flooding. Why would that matter? Because runoff. More runoff into the ocean. Which would decrease the salinity. Or, because of the high precipitation, we're going to kind of get towards the same reason. It's going to be less phytoplankton productivity, but more precipitation causes more cloud cover and a decrease in light intensity. For photosynthesis. And there's one more, it's just like an overall statement. Because of these factors occurring, there's less fish breeding. These are the explains. And you need any three of these. So the one from what is the effect, and then the reasons for it. Now, I'm just going to jump here really quick. I know you guys don't have this as a copy, but could be a question. Anchovies feed on microscopic algae. Anchovies are your small fish. Called phytoplankton. During El Nino events, there's changes, sorry, sounds vague, and the anchovy population have been recorded. Explain, so why? Explain how the El Nino event could affect the population of blue sharks. And there we have that vague statement again. It could affect population. Population is a number. Numbers can go up, numbers could go down. That's how they could be affected. So we're going to want to start with, here's the effect, and then I'm going to explain how. Ultimately, we see in the picture, blue shark is feeding on anchovies. Tells you at the top. So if there's a decrease in the anchovy population, we're going to have a decrease in the population of the blue sharks. And obviously we're not going to put we're not going to put arrows either on your actual exam. So this is how the population will change, and the rest is going to be the why. Our trade winds weaken, or they reverse. Causing less upwelling. Which decreases nutrients. The phytoplankton population will decrease. Which will cause a decrease in anchovy population. Or you can refer to the anchovies as the shark's food source. So a decrease in anchovy population or a decrease in the food source. These are all the whys for the explain. This bottom question, very similar. We have 5 marks there, and it's a very similar answer. So explain the cause of El Nino event. We're going to want to talk about trade winds are weakening, they're reversing. How could this cause the collapse of the Peruvian anchovy population? Okay, I'll just talk it out here. We'll have, again, just like a decrease in the strength or weakening of your trade winds. We could also talk about the reversal. This keeps warmer water off the coast of South America. Less upwelling, less nutrients go to the surface. So we'll have less of a phytoplankton population or less productivity, less of a food source or organic material for the anchovies. This question stopped at the anchovies. Here they also brought in what we talked about with the precipitation altering the salinity. And it said, how could that affect fish populations? This question's very similar. It's not just fish, it's specific to anchovies. It's not going to change what's actually happening. So we could, again, talk about warm, moist air or warm air is going to evaporate and rise. But that air isn't just warm, it does have moisture in it. This is going to increase rainfall or precipitation, causing salinity to decrease. Additionally, storms, winds, could stir up sediment and increase the turbidity. Clouds could decrease light penetration. That will be another way that would be bad for anchovies because they feed off producers. And if there's less producers, there will be less food for the anchovies. The last one, so this is why I was really specific about you guys answering this completely and including all of the effects to Australia. And this is during an El Nino, and this is from exam question last year. So it is a describe the effects. So El Nino, we have weakening or a reversal of the trade winds. We'll want to start with that. Okay, remember we're going to have fires here. And fish are going to swim away. We don't have any rain. And we're not, because there's no rain, we're not having anything from the atmosphere taking any of that excess heat that's built up in the ocean. Nothing's taking it out. So it's going to alter the temperature. We can also talk about the lack of precipitation. Okay. So start with the trade winds. So we could have a complete reversal, or they could just weaken. This will cause more heat to be stored in ocean water, or just say ocean. Again, that air is not warm air because we don't have strong winds. It's not like blowing over here and causing evaporation. It's not happening. Okay, and we can talk about a couple things then. We start with rainfall. That's rainfall, or you could say not that there's less droughts, but it's causing droughts. This will decrease crops. We could also talk about that. So this is like the effect on like the human community. So decrease the crops or less profit for farmers. Less of a food source for the locals. That would also go in this mark. Because of less rain, I'm just putting in parentheses so that you're still following it. We'll have an increase in forest fires. You can also refer to it as wildfires. And if we don't have rain, we're not having storms. So, to us, that's good weather. That means there's going to be higher air pressure. Higher air pressure results in less tropical cyclones. Again, that's a hurricane or a typhoon. They don't call it hurricanes in the Pacific Ocean. It's a typhoon. A tropical cyclone is what you would call a hurricane and a typhoon. But hurricane and typhoon are just dependent on what ocean they're in. Okay, these are all because of less rain. But wait, there's more. So the warmer ocean water, we already mentioned it's going to be warmer, but I'm just putting it there again for context. Causes fish to migrate to deeper, or you could say to cooler areas. So fish are leaving. Also within this mark, just talking about what it's doing to the fish populations, the warmer ocean water, you could also say there's going to be a decrease in fish catches, like for the humans. That warmer water will have an increase in coral bleaching, like off the Great Barrier Reef. What does that literally mean? It means we're going to have death within like our coral polyps. A coral polyp is one individual. They're all identical. But a coral itself is made up of many, many of these individuals, these individual polyps. They are animals. Inside of their tissues, though, is microscopic, microscopic algae inside of their tissues, and that is called zooxanthellae. As a mutualistic relationship within the coral polyp, it does provide the coral polyp with oxygen, because the zooxanthellae does photosynthesis, so releases oxygen, and corals are animals. Everything that is alive truly needs to have oxygen to do respiration, so they do have a source of oxygen there. Additionally, the biggest one is they supply the coral with glucose, so there is a food source coming from the zooxanthellae. The zooxanthellae have a suitable habitat that they can live in. Zooxanthellae do photosynthesis. They need carbon dioxide. They do get carbon dioxide from the coral, as coral shells, again, are made of calcium carbonate. So we do have a source of carbon there. Okay, final marks. If we're going to have less coral polyps, we've coral bleaching, right? Coral bleaching literally means the zooxanthellae inside of here, they leave. They leave the polyp altogether. All of this is going to cause less biodiversity, so less of different species that are there and less of the amount of organisms in those species. Put in the reefs. Okay, there isn't a La Nina question. If there was a La Nina question, La Nina is what happens here in situation A, your normal situation, except everything is exaggerated. So the winds blow even stronger offshore winds, which means even bigger upwelling of the Humboldt Current. If there's even more upwelling, then we're going to have even more phytoplankton production because more nutrients came up. If we have more phytoplankton, there's going to be more zooplankton. If there's more zooplankton, there's more small fish. There's more small fish, there's more large fish, etc. If there's more fish to catch, there's more money, and there's more food sources for the communities. And that will do it. This will wrap up the whole current section. And if you have this finished, then make sure you go back on Google Classroom and go through the questions, answer them for the just regular currents and global conveyor belt set of questions.